Hello, my fabulous students and Kate. Okay, so today, guys, we're doing exercise 3F. So we're graphing quadratics, but we're graphing them when they're in polynomial form. So what that means is, well, polynomial form, quadratics in polynomial form when it's in the form this, ax squared plus bx plus c, where a, b, and c are real numbers. So an example could be y is equal to x squared plus 2x plus 3, or something like that. Now there's 4 steps to doing this. Step 1 is we're going to find the y-intercept. And we do this by letting x equal to 0. Step 2 is we're finding the x-intercept. So we let y equal to 0. Now, one thing to note here is there isn't always intercepts. But we'll come back to that later. The third step is we want to find the axis of symmetry. Now, if we have a quadratic equation and it looks like this, then the axis of symmetry is just the middle line here, where if it's flipped, it's symmetric. So there's 2 ways you can do this. The first way is it's halfway, or I should say halfway between the 2 x-axis, the x-intercept, sorry. So that's saying, but we can only do that if we do have x-intercepts, because we don't always have x-intercepts. So if we had a quadratic up here and it intercepted at -2 and -4, well, we know that the axis of symmetry will be at -3, because that's halfway between. But you can see up here, well, there's no x-intercepts. So you can't actually do that there. So the second way is just a formula, and it's just -b on 2a. And the fourth step is we want to find the coordinates of the turning point. So just a refresher, the turning point is this point here and this point here. It's where the graph turns around, so it goes down, 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 and then it turns and it decides to go back up. Now how we do that is we sub the axis of symmetry, so this fella here, the x value, into our quadratic, and you'll get a y value. And then you just combine the x value and the y value, and you'll get some coordinates. And that's the point. So that's a lot of info. Let's just do a question then. Alright, let me zoom out a little bit. Alright, so let's look at question 3a. So we want to graph y is equal to x squared minus 1. Now the first step is we want to find the y-intercept. So what we do is we let x equal to 0, which will give us y is equal to 0 minus 1, which is minus 1. So we've got our y-intercept here. Now we want to find our x-intercept. So we let y equal to 0. Alright, so we get 0 is equal to x squared minus 1, which means if we plus 1 to both sides, we'll get x squared is equal to 1. And then if we take the square root of both sides, we'll get x is equal to plus or minus the square root of 1, which is plus or minus 1. So remember, when you take the square root of a number, so if it's x squared is equal to a, then x is equal to plus or minus the square root of a. You've got to remember this plus or minus here. Very common mistake. So our x-intercepts are at plus or minus 1. So let's start to graph it. So we know the y-intercept is going to be at minus 1. So we'll put that down here. We know the x-intercepts are going to be at positive 1 and negative 1. So it's going to pass through these 3 points. Now the third, let's find the axis of symmetry. Some of you might be able to just see this from looking at the graph. So you can either find the midpoint of the two x-intercepts. So the midpoint between 1 and minus 1 is clearly 0. But let's use the formula up here. X is equal to minus b on 2a. And what we mean by minus b on 2a is, well, we look back up at this polynomial equation up here. So minus b, so b is the number in front of the x coordinate. A is the number in front of the x squared. B is the number in front of the x. A is the number in front of the x squared. Okay, well, there's no x here. So b will be 0. And there is an a. A is 1. It's just this number in front of the x squared. So it's 0 on 2, which is just 0. So the axis of symmetry is x is equal to 0, which is what we kind of knew. And then to find the turning point, we sub x is equal to 0 into our quadratic equation, which is y equals x squared minus 1. So that'll give us y is equal to 0 minus 1, which is minus 1. So if we use this information here and this information here, we'll get our turning point of 0 minus 1. Perfect. So we can draw our quadratic equation. It's going to pass through this point here, and then it's going to turn around at 0 minus 1, and then head back up. And that makes sense. We know it's going to be a smiley face because it's a positive coefficient in front of the x squared. Okay, let's do 3g now. So we've got y is equal to minus 2x squared minus 3x. The first thing that's different from this one is you can see that it's a negative in front of the x squared. So we know it's going to be a frowny face. Alright, so let's find the y-intercept first. So we let x equal 0. So we'll get y is equal to, we'll get 0 minus 0 there, so it's 0. So we know it's going to intercept the y-axis at this point here. We'll do our x-intercept. So we'll let y is equal to 0. So we'll get 0 is equal to minus 2x squared minus 3x. Now, I'm going to take them all to the other side because I like dealing with positives more. So we'll get 0 is equal to 2x squared plus 3x. Alternatively, you can just say, let's multiply by minus 1. Now let's do some factorizing here. So we'll get 0. We'll take a common factor out, which is x. And that'll leave us with 2x plus 3. So I've just taken the common factor of x out. Now, what we can see here is that this will equal 0, this will equal 0. So I've got x is equal to 0, and 2x plus 3 is equal to 0. This is in a nice simplified form, so we know it's going to intercept the x-axis at the point 0. But we've got to solve for x on this side here. So 2x equals minus 3 if we minus 3 off both sides. And then we'll divide by 2. And we'll get x is equal to minus 3 on 2. Okay, so we know that at this point here, minus 3 on 2, it's going to intercept the x-axis. Alright, let's do our axis of symmetry. Again, you can find the midpoint between the two x-intercepts, but I'm going to use this formula again, as it always works. So minus b on 2a. Well, our b here is minus 3. So it's minus b, so minus 3. And our a is minus 2. So that'll give us 3 on top and minus 4 on bottom. So minus 3 on 4, which is minus 0.75. So again, we know the axis of symmetry is going to be just here. And we know it's a frowny face as well. So we know that the vertex, the turning point, is going to be somewhere up here. We don't know where, but we know it will be. Because if it was below, it would be a smiley face. And we're not expecting a smiley. So what we'll do now is to find the turning point. We're going to sub x equals minus 3 on 4 into our quadratic, which is y is equal to minus 2x squared minus 3x. Oops. So we'll get minus 2 minus 3 on 4 squared minus 3 on 4. Okay. So minus 3 on 4, if we square that, we'll get 9 on 16. And here, well, this will become a positive because it's a minus 3 times minus 3 on 4. So it'll be positive 9 on 4. So here we'll get minus 9 on 8 plus 9 on 4. I suppose we can simplify this a little bit. So we'll get positive 9 on 8. Is that right? Yes, that is correct. So our turning point would be minus 3 on 4 from here, and then 9 on 8 from here. So we'll go up to our graph, This is minus 3 on 4. And then up here, we put 9 on 8. Obviously, it's not to scale. And so that's where it's going to turn around. So it's going up, and then it's starting to decrease. It's always nice to label your graphs as well. Alright, let's do a couple more. Hopefully you know that you can pause this as you go along. Cool. Let's do 4a now. So we've got y is equal to x squared plus 3x minus 10. So again, step 1. We're going to find the y-intercept. Now a trick, the y-intercept is always going to be this number here. That constant term. So the y-intercept is y equal to minus 10. Now, we know it's going to be a smiley face as well because it's got a positive coefficient, so we're expecting a smiley. Now we'll look at 2. We want to find the x-intercepts. So we'll let y is equal to 0. So we'll put 0 on the left-hand side, and we get x squared plus 3x minus 10. Now you're probably getting pretty good at factorizing from this point. So we needed two numbers, a and b, such that a times b is equal to minus 10, and a plus b is equal to 3. And I can see that, well, we got 2 and 5. Looks like 2 and 5 is going to help. So if we have minus 2 and 5, that works. Because minus 2 times 5 is minus 10, and minus 2 plus 5 is equal to 3. So we'll get x minus 2 and x plus 5 is equal to 0. So that means we'll get x is equal to 2 and x is equal to minus 5. So up here we've got 2 and here we've got minus 5. Alrighty. Now our axis of symmetry. So we've got x is equal to minus b on 2a. So our b here is 3. And our a here is 1. So that'll give us minus 3 on 2, which is about negative 1.5, or it is negative 1.5. So we know our axis of symmetry is going to be somewhere here. Okay, and then we'll find our turning point. So we sub in x is equal to minus 3 on 2 into our quadratic, which is y is equal to x squared plus 3x minus 10. So that'll give us y is equal to minus 3 on 2 squared plus 3 minus 3 on 2 minus 10. Alright, then we get 9 on 4 here, and we'll get minus 9 on 2 minus 10. So we'll simplify this, so we'll make this over 4 instead of 2, so we'll get minus 18 on 4, and we'll make this over 4 as well, so we get minus 40 on 4. That's annoying. Minus 58, so it's like minus 49 on 4. Is that right? Sure, let's do that. That could be wrong, but I can't be bothered to check. Tell me if it is. I should be right. And that's nearly -5. So if we come back up here, my computer wants to let me. No, I think that is wrong. Let me fix it. Yeah, that's wrong. Where did I go wrong? Nine on 4 minus 9 on 2. Oh, right, okay. Yeah, so that's about minus 12.25. That makes more sense. So my calculations weren't incorrect, but I had a stroke. All right. So here is like minus 12.25. And so our turning point will be here. Cool. That makes sense. I have no idea what's happened here. Anyway, minus 49 on 4, which is approximately minus 12.25. Cool. Now let's do 4b. It's the last one we're going to do. Okay. So we've got y is equal to x squared minus 5x plus 4. So our y-intercept is just y is equal to 4. Cool. Our x-intercept will let y is equal to 0. So we get 0 is equal to x squared minus 5x plus 4. And then again, we've got to factorize. So we need a times b is equal to 4. And a plus b is equal to minus 5. So we got 1 and 5. Oops, that's not correct. 1 and 4. And 2 and 2. Yeah. Well, if we make this minus 1 and minus 4, we've got minus 1 times minus 4 is equal to 4, and minus 1 minus 4 is equal to minus 5. Cool. So we'll get x minus 1 and x minus 4. Okay, so that'll give us x is equal to 1 and x is equal to 4 as our two x-intercepts. So let's draw it up here. So it's going to intercept, do you want to switch to tablet mode? Sure. It's intercepting at y is equal to 4. Alrighty, Yeah, so it intercepts the y-axis at 4 and it intercepts the x-axis at 1 and also at 4. Now, axis of symmetry. We know it's going to be at somewhere in between here. And if you just use this formula again, minus b on 2a. Our b is minus 5 and our a is 1. So that'll equal minus, and then you do minus 5 on 2 times 1. So that'll be 5 on 2, or 2.5. And lucky last, want to find our turning point. Oops. So we sub in x is equal to 5 on 2 into our equation. Y is equal to x squared minus 5x plus 4. So we'll get y is equal to 5 on 2 squared minus 5 times 5 on 2 plus 4. So that'll give us 25 on 4 minus 25 on 2 plus 4. And let's simplify this a little bit. Make them all common denominators. Oops, I made a mistake, so this should be 16 on 4. And that'll give us minus 9 on 4. Okay, so then we can go up here, because we know our turning point is going to be at 5 on 2 and minus 9 on 4. So let's go up here. We can draw minus 9 on 4 here. So it's going to turn here. Alright, this is going to be an absolute shocking one, actually. So maybe I'll change it slightly. I'll draw it up here. Okay, so we're going to go up here, and then somehow we're going to make it go through there. That's truly horrendous. But you get the gist. Okay, so let's go back up to our, if my computer wants to not freeze, our learning intentions and success criteria. So just to recap, well, when we're given a quadratic in polynomial form, so a form like this, we can find its y-intercept, that's the step 1, find its x-intercept, that's step 2, find its axis of symmetry, step 3, and then find its turning point, step 4. And once you've done that, you can graph it. Awesome. Like and subscribe, etc., etc.